The International Space Station is actually not that far away. It can be seen with the naked eye, passing like a bright little dot on the night sky. And going there only takes about 6 hours.
The first module of the ISS was sent up in 1998. And since November 2000, it has been continuously crewed, and more than 250 people have spent time in this constantly free-falling laboratory. And today we will talk to one of them, Jessica Meir.
We recorded this interview in September 2020, at a peak of the COVID pandemic. And if returning to Earth is usually challenging, returning to a world in isolation is even harder. My name is Susanna Levenhaupt.
My name is Marcus Pettersson.
And this is Have We Gone to Mars Yet?
Going to space is a lot like putting yourself in isolation together with a small crew of others in the same position. Many astronauts return to Earth with an enhanced appreciation of all the things we have down here that are unavailable out there. Now imagine coming home after months in space to a world in quarantine.
Jessica Meir went to the ISS in September 2019 and returned to Earth a bit more than 6 months later. During her time there, she was busy doing a whole lot of research and no less than 3 spacewalks, one of which was the very first all-female spacewalk together with her fellow astronaut Christina Koch. But down here, COVID struck.
So, returning to Earth, Jessica went straight into a different type of isolation. We called her up at NASA once she'd had time to adjust to the situation. So, Jessica, how are you? All good?
Yeah, I'm doing well. I've been traveling and I it was a bit strange. I got back in the middle of April and into the middle of COVID. So that was quite something to return to. Couldn't really do most of the things that I had been missing and really wanted to do. But those first 2 months, you're really busy here at NASA anyway. I mean, you're doing a lot of the experiments and medical testing kind of stuff, getting all the data collection for how our bodies are being affected, of course, once we come back to gravity. And you've got some debriefs and to make sure that we're capturing all the pertinent mission information and passing it along to the right groups, and some interviews and that kind of thing. So those first 2 months are really busy. And in the first couple of weeks, you're really tired. You're just the physical toll of returning back to gravity and getting used to it again does kind of take a lot out of you. So those first 2 months were really busy. And then after that, is the time when we would spend, traveling and doing a lot of outreach and PR and interviews like this, but in person. And of course, that has changed significantly where we're not doing any of those things, at least not the traveling portion. So instead doing all of this brand new virtual world. So I've actually been on vacation a bit and traveling, and I think I really needed to immerse myself in nature a little bit because after those first 2 months were so busy and, kind of adjusting to COVID and everything, I got a little bit depressed. And so I got in my car and drove to my sister's in Colorado and spent some time hiking in the mountains. And then I was in the Lake Country, and then I was in Southern California at my brother's. So it's been nice. I kind of just really immersing myself in nature and appreciating all the things that I was looking at for so long from space. So I think that did the trick and cured me.
That's good to hear. I can imagine how much you miss just feeling the nature instead of just looking at it.
Yeah, it's really interesting. I thought that would be the number one thing that I missed. People always ask us what we miss when we're in space. But actually, I didn't miss anything. Of course, it is kind of ironic when you're looking down and you have the most beautiful view of the planet and you see all these different landscapes and all these different ecosystems. And it's almost ironic that you have the most incredible view, but you can't touch or immerse yourself in any of them. But at the same time, I didn't find myself really missing anything. And I think that's because, when we go to space, it's such an alien environment. Everything is different. And if you're at home sitting on your couch and you remove something that you're used to having, of course you're going to miss it. But when you go somewhere completely new where there's unbelievably exciting things happening all the time, I just found myself really not missing anything from Earth, really. If I just thought about it, like, oh, it would be nice to be out in nature and smell the trees and to jump into the ocean, sure. But I didn't really miss it like I think I would have if I were still at home.
Last time we spoke, You hadn't actually been in space, but now you have. So first of all, welcome back. But tell us, what has changed for you? Has the experience of being in space changed you or your perspectives in any way?
Well, tusen tak, first of all. I guess I would say it's nice to be back, but to be honest, I'd rather still be in space. I would have definitely stayed up there longer if I'd had the option. Yeah, it's interesting. I thought about going to space from the time that I was 5 years old, since that was first when I said I wanted to be an astronaut. And I thought a lot about that as an adult, and especially after getting this job, about what it would be like. And there is this phenomenon called the overview effect that Frank White wrote about, in terms of how you really are changed as a person when you see the Earth from above with your own eyes. And I think that that's absolutely true. For me, environmentalism was always very important to me. And I've heard a lot of astronauts describe how profound that is when you look back at the planet and you see how beautiful and fragile and special it is. And it's this blue marble and the void and blackness of space around you, and this thin, tenuous band of an atmosphere. And you do see how fragile it is. I was really struck by how special you see this band of the atmosphere. Not only is it thin, that had been very well described, but I didn't realize how different. You could really see a whole gradient of hues of blue as the air gets thinner and thinner and thinner with altitude. And that's something I think is a little bit lost in photographs. But with your human eye, you can see this just transfer of the air getting thinner and thinner. It's really extraordinary. And just feeling how special it is and how important it is that we protect our planet. I had thought a lot about that before, but I think it resonated even more loudly after seeing it with my own eyes. And in that, especially during my mission, first just from that environmental standpoint, but then with COVID and the outbreak of this global pandemic that we were literally watching unfold from up above, just this feeling of interconnectedness. It's so easy from space to realize and just to feel that we really are all one. And that's just something that I wish that all humans and all world leaders really could see, because I think it would change how we do things as humans. It's so easy on Earth for everybody, including myself, to just get caught up in what's in front of us and things that don't really matter in the big picture, superficial things or whatever it is. It's so easy to get caught up and wrapped up in those. But from that perspective, from space, it's impossible to not see how connected we are and that we are really all in this together. And that's why it's so important to me to try to share my mission in every way, whether it's through interviews like this one or through pictures that I've taken or however I can share that experience, because it's not, I certainly don't look at it as my mission. I look at it as everybody's mission. I'm just the one that was lucky enough to be up there.
Yeah, so you were up on the ISS for 204 days. What did you do there?
I think it was 205, but I'm not sure. That's what I always say. I better check the actual.
Okay, with traveling days.
Yeah, okay. So what were we doing? We were incredibly busy, especially during the first 4 months of our mission. Well, really through the whole thing in different ways. But we had more spacewalks than are normally done in one expedition, just because of the timing of the way everything worked out. So we were very, very busy with spacewalks, which are one of the most time-consuming things that we do, and really consuming personally as well, because they're the most challenging thing that we do, both mentally and physically. So we had 9 spacewalks in a period of 4 months, which was really kind of unheard of. We had a lot of different cargo vehicles coming to resupply the space station, to bring food, to bring new experiments, to bring supplies. That takes a lot of time for us. We have to use the Canadarm to actually grapple that vehicle and catch it and pull it in. And then we have a lot of cargo operations, getting things out of the vehicle, putting things back in. But our primary purpose for the space station is, of course, science. So we are doing all kinds of scientific experiments, ranging from how microgravity and the spaceflight environment affect our human body. And that helps us understand, not just how to bring us back and how to keep us healthy and bring us back safely, but also for longer duration travel. When we go back to the moon and we eventually go on to Mars, these are all lessons that we're bringing with us. We do combustion science experiments. So even flames burn differently without gravity. You don't have convection. So that affects, of course, all of the properties of how things burn. And that has applications with fuel efficiency in vehicles on Earth, but also future spacecraft propulsion systems. We do protein crystal growth experiments, which have had a lot of pharmaceutical applications. So proteins can grow larger and more pure in microgravity. There was a Japanese experiment relatively recently that now has led to clinical trials for Duchenne's muscular dystrophy. So lots of different things that benefit us not only in space, but also benefit humans back on Earth. And I mean, I could go on and on and on, but there are experiments of all types: chemistry, biology, physics, material science, radiation, that we really are this world-class lab up there. And as a scientist personally, that is just so exciting to be up there contributing to all of these different experiments, gathering data for them, conducting the experiments, and really helping progress and further science for everybody.
So why don't you just perform these tests down here on Earth? Why is it important to have a lab in space?
Yeah, it's important to have this lab in space because we have this there are many differences in terms of the environment, but the biggest one, of course, being the lack of gravity. And we can't replicate that on Earth. So if you think about that as a scientist, and you always have kind of the elephant in the room of this 1G gravitational vector that you're experiencing right now, that every system is experiencing right now, whether it's biological, chemical, physical. So you can't remove that completely on Earth. If you remove a really big variable like that from any scientific system, there might be profound changes and implications and things that we can discover without that. Remove that elephant in the room, who knows what's going to happen? And that's really how basic science works, of course. Sometimes the most significant outcomes are the things that we're not even expecting. So because we have that completely different environment, like I mentioned, even the protein crystals are able to grow larger and more pure. So that's simply because there's no gravity. We can't do that same kind of experiment here on Earth. So it really opens up a whole new realm of possibilities in terms of scientific research and investigations.
So there's a ton of research being done up there, but which projects were your favorites?
My particular favorites, because my background is in physiology, I was really interested in a lot of the physiological experiments that we were doing. And we were also doing some experiments with rodents that were really interesting, that kind of did make use of some of my background working with animals and doing experiments with animals. And one of those experiments was looking at the effect of circadian rhythms on things like liver disease. There was another experiment that had some altered mice, and this study was just published, so really exciting. I was so proud to be a part of it. There is something called myostatin. It's a hormone that helps limit and inhibit muscle growth in you as healthy humans and in animals as well. And so implications of that system are really part of a lot of bone and muscle degenerative diseases on Earth. But also, if you're thinking about the atrophy of muscles and bone density loss with astronauts when we don't have gravity, there are a lot of applications as astronauts as well. This was a really interesting study where we had myostatin knockout mice. And these mice, there was one group that didn't have the gene to express that. And then there was another group of mice that we were giving injections to that basically had the same effect on the system. So the myostatin was inhibited. So they didn't have this inhibition of muscle growth. So we called them mighty mice. They were bigger, they were stronger. And it was really interesting. The results were that this group of mice that had received the treatment, they were able to preserve their bone density and their muscle mass throughout the whole mission compared to the control mice. So really significant implications for the future of space travel for astronauts, but also for a lot of disease and medical conditions with patients on Earth.
So in the future, we could cut that gene from astronauts and we wouldn't have to worry about muscle atrophy?
I'm not sure it's that simple. Of course, a mouse model can have a lot of implications to us as humans, but that's kind of a first step in thinking about different therapies. And I would imagine that if we just cut that gene out of humans, you would have a lot of other problems. Instead, you wouldn't be able to just breed a human that way and then launch it and it would make a great astronaut necessarily, because I think it would have a lot of other hosts of problems. But there are a lot of implications for different therapeutic strategies that could have implications for astronauts.
Yeah, so do you now, when you're back on Earth, do you do follow-up research on that, or is it other people that follow you?
Yeah, it depends on the particular experiment. So all of the experiments that are done on us, and there are a lot of experiments that I was a subject for. So looking at my blood vessels, for example, looking at all of my different physiological systems. So of course we're involved in those ones because we have to turn up and be experimented upon in order to collect the data. This experiment that I described to you about the mice was a little bit different in terms of the fact that I actually helped them at the end in writing the scientific paper. So we're actually listed as co-authors on this investigation, which isn't always the case. So I was a little bit more connected to this one. So it's kind of variable, but it's more, the particular scientists involved are the ones that are following up with everything, and we're kind of just the hired labor up there conducting the experiment. But if you want to be involved, then like I did, then you can be in a different way.
I'm just curious about when you do tests on mice on the ISS. Is there a possibility? Could the mice escape on the station?
We actually have a whole team here that worries about all that kind of stuff for us. They've developed these special habitats to try to prevent that kind of thing. We do all of this work with mice in a glove box. So they are in their own kind of isolated environment. You're working through gloves. And there, of course, are some transfers involved, but we have a lot of training, and that's how we try to mitigate things like that. So we are, constantly trying to keep ourselves and the mice and all the animals, of course, safe and have all the protocols in place. It's definitely a possibility that one could escape, but we never had that happen. So,
but what would you do if it did?
Well, we would do our best to find it, and hopefully we would, I guess.
You, as an astronaut, are not just a researcher and an astronaut, obviously. You're also sort of a lab rat yourself, right? When you're on the ISS, because you have a lot of tests done on you. Tell us about that.
Right, absolutely. And that's what I was alluding to in terms of all the physiology and medical experiments that we are the subjects for. And I think it's kind of interesting for me, especially since I actually worked in that group many years ago as a scientist, supporting those experiments way before I was an astronaut and doing those on other astronauts. And then I went back to graduate school and I was doing work with animals. So now I'm doing physiological experiments on animals like emperor penguins or elephant seals or geese. And now it's full circle where I am exactly that. I'm the guinea pig. I'm the lab rat. And, I find that part incredibly interesting and so valuable. I really do think it's one of our responsibilities to give back. We're so lucky to be the people that go to space. And there are so few of us that data is very precious and very important. So I volunteered for all the experiments possible that I could that were being conducted at the time. And I really enjoy the opportunity to add to that data set. And I find it interesting too, as a physiologist, I'm always asking the scientists those questions. Well, what's happening and what is this? And, trying to look at the data myself and stuff as well. So there's everything from, for example, one of the studies was looking at the health of our blood vessels. And some of their previous studies have shown that the carotid artery, so artery walls in general, and they looked at the carotid and other arteries, are becoming stiffer and thicker in space. In the period of 6 months, about the equivalent of maybe 10, 20 years of aging on Earth. So something really significant. Why is that happening? Is it the radiation? Is it the differences in blood flow because of the lack of gravity? These are the answers. These are the questions that we really need to find answers to make sure that we keep astronauts safe and bring them back home safely. And so we did a lot. We were using ultrasound to look at all of these different blood vessels. That was just an example of one of the experiments that I was a subject for.
Now, when you're back, you've been home for a while. Has your body adapted back?
Yeah, so there are a lot of physiological changes. And the good thing is that since we've been going to space now for 50 years, we have decades of research, and we've been looking at all these problems for a long time. And for me as a physiologist, it's really interesting to think about, because in the beginning, we didn't know. When we were starting the first missions to go to space, physiologists and medical doctors didn't know what would happen without gravity. They had a lot of really valid questions like, will you be able to swallow? Will you be able to eat and drink? What will happen to your digestive system? Aren't these things, they do seem to be dependent on gravity in some way. So can humans even survive in space without gravity? I mean, people really were asking some of the most basic questions because, of course, we didn't know. And now decades have gone by and we do have a wealth of information and data on that. So we know how to keep astronauts safe. And two of the biggest areas we've talked about a little bit with that mouse experiment and others are the bone density loss and the atrophy of muscles. So when you go to space and you don't have the constant loading of gravity, You and I are sitting here right now in chairs. We're not exercising, but we still are reacting to the loading of this gravitational force all the time. That's actually keep stimulating your bones and muscles and keeping them active and healthy. Of course, you still need to exercise to really get the full effect, but some of that bone health is just from that physical loading, even when you're doing nothing. So when you go to space and you don't have that loading anymore, your bones actually start leaching calcium. And if you didn't somehow load them, you would have a significant loss of bone density. And the same thing for your muscles. You're just not using all those postural muscles in our backs right now when you're even sitting up. All of those systems are active, and they're not in space. So we have to exercise. The good thing is, because we've been studying this for so long, we have incredible exercise equipment up there. We have a lifting machine, we have a treadmill, and then we also have a cycle ergometer. So we are able to actually offset that bone density loss and that muscle atrophy. So when I came back, I actually had, they look at all the different areas of bone. And so some change or go up or down. They're not all uniform. But we're bringing astronauts back now, pretty much keeping them baseline, maintaining bone density, maintaining that muscle mass. I came back with more muscle mass actually, since we're lifting weights every day. So that part is good. We are able to offset those things. There is something else that goes on, of course, just without having gravity all the time. You come back from space, and those first few weeks are actually quite difficult because you feel really tired. You feel physically like somebody's pushing you down into the chair. Like you can actually feel gravity. And of course you can, because you're not used to having it. And so it does take some time for that to come back. Your vestibular system is quite affected. Our inner ears are very gravity dependent in terms of how we have our sense of balance and our sense of spatial awareness. So that takes some time to readapt. That system really goes a little bit haywire going up and coming down. So that does take a little bit of time, but after, I was quite lucky. I felt well going up and coming down. And then you just kind of readapt to it. It took me, it takes a little bit longer then to start running. So you feel normal when you're walking, but then because running is a little bit more of a complicated movement with this brain and neuromuscular connection, it felt very strange to run. That took a little bit of time, and I felt like I couldn't run quite as quickly for a little while. And most people have a little bit of back pain in kind of readjusting because, the discs in your back expand and move, they aren't being pressed together. So that takes a little bit of time. But I would say after, I felt pretty good after a couple of weeks. After 3 months, I probably felt 100% normal.
Your first spacewalk was not only your first spacewalk, it was also the first all-female spacewalk ever. So I'm wondering, which of those two aspects was the biggest for you at the time? Was it being in space for the first time, or was it being part of a historical event like that?
I think really the answer to that is both, but it evolved over time. And I would explain that by saying, when I first went up there and got to space, I'd only been up there for a couple weeks before that spacewalk was scheduled. So I was still like a newborn figuring out how to drink and eat and do all these basic function things, which are completely different when you're in space. You're trained very well for all the technical aspects. That stuff's not difficult because you're ready for it. But nothing can prepare you for living without gravity until you're up there. So that takes some time. And then I had to focus on the spacewalk because spacewalks are the riskiest and most challenging thing that we do, both physically and mentally. So I needed to put all my focus in making sure I was ready to do that spacewalk in terms of knowing how to get the job done, how to get the job done effectively and safely, and how to keep myself safe, and also, help out Christina, my partner, if any situations were to arise. So that was what I was focusing on. Especially because that spacewalk was my first and had occurred so early on in my mission. I would say that after the spacewalk, and maybe even perhaps a bit during, my view on that did shift a little bit to appreciating the significance of it. But for us, part of it is just us going out the hatch to do our job that day. The fact that it was me and Christina, to me, wasn't necessarily that important in terms of getting the job done, because everybody up there, all of the crew members had received the same level of training. They were all qualified to get the job done. So it didn't matter who I was doing. It just happened that day it was me and another female, and that hadn't happened before. And for us, our class, we came in 2013. It was the first time that there was 50% female and 50% male. We were all held to the same training regime and held to the same standard. So we knew that we were all ready to do the job regardless of our gender. So part of it is just us doing our job that day. And I think that was more what I was focused on that day, getting ready for the spacewalk, just making sure that I knew how to get the job done and to keep us safe. That was my priority. But then, that did shift a bit when quite honestly, I was really overwhelmed by the level of enthusiasm and support. I did not expect that many people to be paying attention. They're really, in everything else that we do at NASA, people aren't really paying as much attention anymore. There's so much going on in the world. There's so many things for people to focus on. People aren't necessarily aware that there's a spacewalk going on, let alone like tune in to watch it. They're actually pretty boring to watch if you don't know what you're watching. They're pretty slow. So I was really shocked by how many people paid attention, and that meant a lot to us. We felt so privileged to be up there and so proud to be a part of it. But I think it was important just for science and technology and all the STEM fields and for NASA, and the fact that all these people were paying attention to what was going on. And the fact that it did inspire so many people, I was really shocked by how much it touched people, how much it seemed to affect them and move them. And that meant so much to us just in terms of, inspiring people. It inspired us as well and really just made us feel so proud to be a part of it. And I guess the last thing I'll say about it is, I don't really look at it as, oh, I'm a part of history. Christine and I did this great thing. We don't really look at it as a personal achievement. We happen to be the people that went out the hatch that day. It really could have been anyone that had the same training that we had. But what makes it special are the generations of women and minorities and people that did have to push those boundaries, that did break those glass ceilings and push things further. They didn't always have a seat at the table, and we still don't have an equal seat at the table, of course, in many respects. So it was really in paying homage to them. That's what I wanted to get out of it, and that's what I hope people really appreciated. They were the ones that did the hard work. I just went out the door and did my job that day, but it was because of them that I had that opportunity. And that was, Christina and I are both incredibly grateful and thankful for that.
So how does NASA look at equality in space in the future?
That's something that's very important to NASA in terms of how we select astronauts and making sure that everybody is represented, that we really are, as NASA astronauts, we are the face of America. And so making sure that everybody is equally represented is very important to our mission statement, to how we select astronauts and to what we do. So, I think although it was never NASA's idea to do a first all-female spacewalk as a thing, that's just not how we do things at NASA. We did it because it was the right decision that day to accomplish the mission. Now, of course, we should still pay attention to it and recognize it as an achievement, but it's, it wasn't the intention of it that day. But, I think that we look at it as everybody else does in terms of trying to make sure that we do represent everybody equally. And that's easier said than done, of course, and has been a challenge for other government agencies and for private companies and really for just people in general, especially when you look at the civil unrest that's sweeping across the country again, here in the U.S. And so all those things are incredibly important, and we do need to pay attention. I think the only right way to go forward is to make sure that we all go forward together.
Do you miss being in space, and are there any future plans for you going back?
I absolutely miss it. I've been thinking more about going back to space probably than I have been on being back here on Earth. If it were up to me, I would have stayed longer, and that's not just because of COVID. It was much too short for me. Even 7 months, I wasn't ready to come home. So I do hope to go back. Normally we come back and it takes your body time to recuperate after a long duration mission. And, since things did go well, there's a very good chance that I'll have another mission. I don't know what or when that will be, but I hope to play a role in whatever the next mission is, whether it's back to the space station, whether it's being involved in the Artemis missions, sending the first woman and the next man to the moon. All those things are in the realm of possibility right now, given where we are at NASA and as active astronauts. So I hope so, but we'll have to stay tuned and see what that will be.
Let's hope Jessica is on that Artemis mission when that day comes. Her next historical walk might be as the first woman to set foot on the moon.
I'm keeping my fingers crossed for her. But until then, please subscribe. There is more to come. My name is Marcus Pettersson.
My name is Susanna Levenhaupt.
The music we play is composed by Armin Pendek.
Have We Gone to Mars Yet is produced at Beppo by Rundfunk Media in collaboration with Rymdkapital. Read more about them and how you can get yourself involved at havewegone-to-mars-yet.com.
Hallå? Programmet gjordes av Rundfunk Media.